Welcome to Machine Learning in C++ with Tyler York. General process and types. For a more concise understanding of machine learning and its applications, we can start by describing the general components. The general types of machine learning are classified as follows. Supervised learning. This approach is when an algorithm learns from a given set of example data and the associated target responses, which normally consist of numeric values or labels and features. Unsupervised learning. This approach is when an algorithm learns from regular examples of which have no primary association of response. The algorithm generally in this case is left to figure out the data patterns on its own. Reinforcement learning. This approach provides an algorithm with examples that lack labels, but the features of the program are given an associated positive or negative feedback, which is the function of which the machine learning algorithm makes decisions. And finally, semi-supervised learning. This approach functions whereas the algorithm has an incomplete training signal, and through the process of transduction does the algorithm know its output at learning time. You can tell what things are important by the fact that I labeled them in red. Interesting implementations. The first one is fake news detection using machine learning. And the second one is predicting breast cancer survival rates using machine learning. All right, number one, machine learning detects fake news. Fake news and false information are concepts that have existed long before the use of the internet and the implementations of machine learning that are detailed in this project. The information contained within the internet and the capabilities of the internet make the spreading of information, whether it be false or true, significantly more pertinent. Some of the most important fields and concepts within our daily lives are subject to the inflation and addition of erroneous information. Machine learning and its implementations are one of the most functional and applicable ways to process fake news and false information. Machine learning detects fake news, continued. The first implementation of machine learning that will be covered is an example of supervised learning by classification. The data that is fed to the algorithm is processed by way of neural layers. These layers consist of three typings: the input layer, the hidden layer, which applies the activation function, and finally the output layer. We will go into more detail about those soon. Below is an example using a row of vectors to initialize neuron layers. The name topology in this example, this is the name of the vector included in the coding segment and refers to the general geometric shape and structure of the neural layers. And this is an example of its implementation in C++. Machine learning detects fake news, continue to. The input layer consists of 2x2 matrices of pixels, which are designed to take the image and break it down into functional units to compare using the activation function and decide whether or not that matrix of pixels has been edited in order to generate a fake or photoshopped image. The hidden layer uses the activation function, which is a function designed based off of whatever specifications are written into the algorithm in an attempt to show that 2x2 matrix as active in preparation of it being fed into the output layer. Due to this implementation of machine learning being supervised, we know from the earlier general explanation that our algorithm is fed a large data set of pictures of which to contrast edited pictures and altered pictures with. After applying the activation function, and it is determined whether or not a pixel matrix should read as on or off, the output layer is responsible for marking the matrix of pixels in accordance with the hidden layer's result. And in our example for this project, it marks layered pixels which have been edited as white and pixels which have likely not been edited as purple. The dataset used and fed to the input layer within this implementation of machine learning is called the theme dataset. It contains examples of real photos, of which are unedited, and fake photos, which have been photoshopped. Thousands of these examples are fed to the algorithm. After enough pieces of data have been processed through the algorithm in its layers, we can see a pattern of activation, which uses purple pixels to denote sections which have not been edited, and highlights sections of the photo bright white if they have likely been edited and photoshopped over the original image. Here's a picture of Kim Jong-un. The picture on the left has been photoshopped and edited and is fake. And using the algorithm, using the machine learning algorithm, we can check what part of it has been edited or if it's been edited at all. If you look at the image on the right, his body and his surroundings are purple, which means that the machine learning algorithm has denoted that section of the photo as being untouched and not edited. But the disk drive in his hand shows up white, which means that the photo has some components of layering in it, which means that the machine learning algorithm is flagging that pixel and its surrounding neighbors as having a likely precedence of being edited or photoshopped in this picture. And I think this is a really interesting and neat picture because it really shows off the power and the precision of the machine learning algorithm. Next, interesting implementation of machine learning. Machine learning predicts breast cancer survival rates. The practical implementation of machine learning comes with varying degrees of importance, depending upon the topic and its relative content. Human beings with a high level of training and specification in some subject matter may very accurately predict an outcome. But when forced to interpret multiple features, human accuracy tends to trail off. Whereas machine learning can manage a large multitude of features and factors. And its implementation in important fields can mitigate erroneous findings and minimize loss. One of machine learning's best applications and most prevalent applications within our waking world is its use in cancer prevention. Continued. The second implementation of machine learning that we will cover will be an example of supervised learning by way of classification. Notably, we have a database called the SEER database, which is a cumulative 657,000 demographic characteristics and information on breast cancer patients. The SEER patient data will be fed into the input layer of our machine learning algorithm and used to determine a predictive outcome. The hidden layer of the machine learning algorithm was used to transform patient data into feature vectors of different characteristics.
So next I included a diagram, which will help us understand this machine learning's implementation. So first we have the SEER patient data, which is the database of all of the information on the patients. Next, it moves into a pre-filtering breast cancer patient process. And what this does is it will eliminate all the people who don't have cancer and all the misnomers and all the outliers. So we just have a chunking of people in their data that have cancer so that we can use this machine learning algorithm to predict their survivability rates. Next, we want to reference the machine learning's predictions against an expert. So an oncologist uses their expertise to deduce what outcome or they think may be or predict what they think the survival rates may be. And after that occurs, there's variable selection, so we have to figure out what exactly it is that we're searching for. And then we have feature vector generation. We generate a vector of features, and these include things like the aforementioned things like age, like cancer rate, like how long it's progressed. Next, we have WECA here, which is the name of the machine learning package. And this is what will be trained in the hidden layer with the different typings of machine learning algorithms in order to see which one's the most accurate and which one will give us the most precise predictions. And it's really just attempting to use 3 different models in order to see which one is the most accurate means of which to produce predictions. And after, so the machine learning package will be processed using logistic regression, native Bayes, and C4.5 decision tree. All 3 of those will be used in the hidden layer. And then after cross-validation, we will have the output layer, which will output the results. And then we have to analyze the results. And here's the references.